Now let's say that your 145 position has gone down $16. Actually, it can't. But let's say that the stock has gone down $16. Okay? That would mean that over time, your position has lost money. How much? Has it lost $16? No. Take a look. Let's just go up here. 150, 155, 160 is very close to $16, and it still has $8.84. You see, Kevin, you just haven't played with it enough to recognize the value. But if you've got an option that has enough time in it, it actually doesn't lose all its money necessarily. And I'm not saying you should run out and buy the options. I'm just suggesting that this is an alternative strategy. And you asked the question, why would you want to buy a Leaps? And I'm telling you why you would want to buy a Leaps. I'm not saying you should. I'm just saying that this is why someone would want to. Make sense? All right. Are you still confused, Kevin? If you're still confused, then you probably shouldn't buy the Leaps. You should probably buy the stock. But for other people who have seen the light, they can understand. You still don't see the point, Kevin? Really? I'm confused at what you don't see the point of, but I must move on. So, Kevin, the best thing you could do is get in touch with a student success coach. Go ahead and write success@tradesmartu.com, and we will see if we can't bring some clarification to it for you. All right, let's get into the really nerdy stuff. This is the option pricing. And option pricing is, this is the fun stuff. This is the stuff that's so exciting. It will make your head spin. So let's get into it right now. As we deal with option pricing, let's go through a couple basics. One of the most difficult aspects of option trading is the pricing models. Maybe, Kevin, by the time we get through this, you'll understand why the Leaps doesn't lose all of its value at once. But for now, let's work through this a little bit here. One of the most difficult aspects in understanding options is the aspect of pricing. That's because there's a lot that goes into option pricing. Specifically, there are two values that make up the core option price. Number one is your intrinsic value. Number two is your premium value. Your premium value is what's tied to the time aspect of your option, okay? Now, premium can be very complicated. I'm going to break it down here in just a minute. I'm actually going to go through all the Greeks and everything here in just a couple of minutes. But before we get there, I'm going to go through intrinsic. Premium can be very complicated. At expiration, here's what happens. Only intrinsic value remains. Now, I get this question quite often from our students. Students always ask me, they say, why do I buy in-the-money options with intrinsic value? They're more expensive. And I say, because they have more intrinsic value. Intrinsic value is the only portion of your option that is still in existence at expiration. It's the only part that remains. Okay, so you really, at expiration, want intrinsic value. Now, all of your option pricing is ultimately going to be derived from the underlying stock. So whatever option you're trading, let's say you're trading options on Apple, then it's going to be based on what Apple stock is doing. The amount of intrinsic value is going to be based on the Apple stock as well as the amount of premium value. Everything in the option price is ultimately built on the price of the stock. That's why we study stock price. The reason we don't sit here and chart option prices is because it's not practical. You're charting the derivative of what actually makes the price move. When we study the option price, we're studying the the stock price, we're studying the underlying price of that option. And that's why we want to do most of our decision making based on the stock price itself. And then we can look at the option pricing and we can build our discussion from there, okay? So let's break it down and let's see if I can bring some clarification to you. Intrinsic value. Intrinsic value represents real value. That's the easiest way that I can say it. At expiration, only the intrinsic value will remain. And so, thus, it makes sense. The more intrinsic value you have at expiration, the better it is for you. And another note here is intrinsic value cannot be negative. You cannot have a negative intrinsic value. So when you're thinking of your option price, here's the formula over here on the right. It's always intrinsic value plus premium value equals your option price. This is the formula. That's how you get to your option price, okay, your basic formula. Now, to discover intrinsic value, here's the formula. Stock price minus strike price equals intrinsic value. Stock price minus strike price is your intrinsic value. Okay, so understanding that formula, let's come over here and let's take an example of some intrinsic value. Take a look at this trade. Stock is trading at $47.25 per share. You decide to purchase a call option with the right to buy at $35 for the strike price is at $35 a share, okay? So you have a $35 strike price. The stock is trading at $47.25. How much intrinsic value do you have? Go. It doesn't matter what the option price is. The intrinsic value will be the same. Okay, so somebody says, well, what's the option price? It doesn't matter at this point. I'm asking a simple question. If the formula is your stock price minus your strike price, the stock price is $47.25, subtract your strike price of $35, that leaves you with $12.25. I'm thinking 25 and I'm writing 3. $12.25. This is your intrinsic value. Now, where does the term intrinsic value come from? Well, understand this. It's built in. The stock is currently at $47.25. It's trading way up here. I put $47.25 and I drew it at $42.50. Forgive me. That's all right. The numbers still remain. That's what I wanted, $47.25. So the stock's trading at $47.25. You have the right to buy it at $35. There's a difference there. Would you rather pay $47.25 or would you rather pay $35? The answer is you would obviously rather buy at $35. Nobody wants to pay $47.25 when you can get it for $35. So how valuable is this call? Well, it's at least worth that difference. That difference is $12.25. Do you guys see the idea here? The difference in the stock price and the strike price, that is your intrinsic value. Now, what do you think is going to happen to intrinsic value if the stock moves from $47.25 up to $50? How much intrinsic value do you have now? Well, you should have about $15, right? We went from $47.25 all the way up to $50. We now have $15 intrinsic value. How do I know? Because the stock is currently at 50. The difference between 50 and 35 is 15. The intrinsic value will always be the difference in the stock current trading price and the strike price of the option, the price at which you have the right to buy or sell. Okay? Now, let's do another example here. Let's say that you've purchased the stock and the stock is trading at $47.25, and you purchase the call option with the right to buy it at $45. How much intrinsic value do you have? Well, again, we're going to take the stock price and we're going to subtract the strike price. That's going to leave us with $2.25. $47.25 minus $45, $2.25. That is your intrinsic value. Now let's do another one. Okay, let's flip it upside down. Let's change this example to the one that I meant to draw. And let's say that you have a $50 call. So you have the right to buy at 50, but the stock is only trading at $47.25. If you have the right to buy at 50 and the stock is only trading at $47.25, how much intrinsic value do you have? Remember, intrinsic value cannot be negative. So what would it be? It would be 0. You cannot have a negative value, and if you subtract $50 from $47.25, that is the strike price minus or the stock price minus the strike price, you would end up with a negative number. We can't have a negative, so you have zero intrinsic value. Makes sense? Now let's go the other direction. Let's do it with puts. Okay, let's do it with puts at this point. A stock is trading at $47.25. You buy the put option, which is the right to sell. You buy the put option, which is the right to sell with a $45 strike price. So you have the right to sell at $45. The stock's trading at $47.25. Well, if the stock's trading up here at $47.25, what is the likelihood that you want to sell for $45? The answer is 0. You don't want to sell for $45 when the stock's trading all the way up there at $47.25. You'd much rather sell for $47.25. So what's the intrinsic value? The answer is 0. Okay, now in this case, we're going to do the exact same thing. We're going to take the strike price. We're going to flip it around. Sorry, we're going to take the strike price and subtract the stock price. Guess I should have changed my formula. It's the same idea. You guys get it. We're just flipping it backwards because the put works inverse. So if I change this, we'll say the strike minus the stock price. That's how we would get the negative value. Therefore, this would be a 0 intrinsic value. Okay, now let's move forward. Let's try one that would be what we call in the money. You have the right to sell. I just did my example totally backwards, didn't I? I'm just realizing I just did my example totally backwards. Please forgive me. And I have a really good excuse. What you guys don't know is I have 2 computers logged in here. One of the computers I read your comments on, and one of them I teach from. And my laptop, where I read your comments from, it crashed while I was teaching. And I've been trying to get it logged back in while I was teaching. And I'm just going to confess the full thing now that you know that I'm trying to get my other computer logged in. So I'm going to finish logging this thing in so that I can read your comments, because I can't see your comments right now. And then I'm going to go back and I'm going to teach that the way that it was supposed to have been taught, which was as a in the money. And then it will all make perfect sense, and you won't think that I'm crazy because I just taught it totally wrong. And you can all smile a big smile. All right. Now, let's do this whole put example the way it was supposed to be. Forgive me. Now I got my computer right. Let's move this back. I can see your comments again. And Ken Fuji has been writing a whole bunch of comments while I was gone. Wow. Great to see all your comments, Ken. You guys actually have no idea how many times this happens in a webinar when I have to log in again and I don't tell you. I'm just that good of a performer sometimes. All right, so stock price is trading at $47.25. You have the right to sell at $45. Now, I still have this right because I did my example wrong. I drew my chart wrong. So my example was totally correct. My example was totally correct. You had the right to sell at 45, but you purchased the 47.25. You could sell on the market for 47.25. My example was totally correct. Here's where my example screwed up. You have the right to sell at 25. I ended up with two zero intrinsic values. That was the problem. So this example is just going to be the same. You have the right to sell at 25. You don't want to sell at 25 because you can sell on the open market at 47.25. Okay, that means you have 0 intrinsic value. Is there any question on how we have 0 intrinsic value? Let's do one where we have intrinsic value with puts. That's what I really wanted to do. Okay, let's do one where we have the right to sell. So now we're going to get rid of the 25 put, and instead we're going to add in here a $60 put, okay? Now we have the right to sell at $60. Is everybody tracking with me? Everybody see what happened here? Okay, so we have the stock trading at $47.25. We have the right to sell at $60. Whoa, that's a big difference. Stock price minus the strike price of $47.25 is $12.75. So you can sell for $12.75 more than the open market. How many of you would rather sell for $60 than sell for $47.25? The answer would be all of you. Every one of you would still rather sell for $60. Okay, so that means that this option, this put option, has become more intrinsic value. It's more in the money. It's got intrinsic value. And by the way, the only thing I had really screwed up in that other discussion was I screwed up this formula. Since I was looking at it upside down and I was doing two things, I actually changed my formula, even though I knew in my heart it was right. It's still stock price minus strike price. So I was still correct. Okay? Still stock price minus strike price. I think I'm afraid I've confused you. Have you guys followed in the money intrinsic value situation here? Or have I totally confused you? Because I have no idea how it came across, seeing as my mind was totally in a different place. Judy wants me to do again. Chris is confused. Okay. I got to do it again. But some of you got it. Great. Let me see. How can I do this one more time and make it really, really clear? Let's do this. I will win. Let's go do another example with Baidu. And let's see if we can't get some option chains pulled up right here in Trade Navigator so I don't have to go log in over there. And let's take an example of Baidu. And here is your scenario. You are going to, I don't even have to have the option chain. You are going to buy a put option at 130. What does a put option at 130 give you the right to do? It gives you the right to sell the stock at 130. So you buy a put option at 130. The stock goes down. Now the stock is trading at 114.14. What is your intrinsic value? We're going to take the stock price, 130. We're going to subtract, we take the strike price, 130. We're going to subtract the stock price of 114.14. And we are going to end up with $15.86. This is intrinsic value. In other words, if the option expired tomorrow, you would still have the right to sell at 130. That's $15.86 more than the current market price of 114.14. Does this make sense? So it's strike price minus stock price. Yes, Mark. Yes. Okay. Wonderful. We got it. Great. Let's move on because I wasted a lot of time there. All right. Let's talk about in the money. Options that have intrinsic value are considered in the money. Easiest way to remember it, intrinsic value in the money. Options with intrinsic value are in the money. Now, how does that functionally work? Well, for a call option, the lower the strike price, the more intrinsic value it's going to have. The lower the strike price, the more intrinsic value a call option is going to have. With a put option, the higher the strike price, the more intrinsic value. Now, why? Well, the answer is simple. The call option gives you the right to buy. You want to buy low. So the lower the strike price, the more intrinsic value. A put option, gives you the right to sell. You want to sell high, so the higher the strike price, the more intrinsic value. Take a look at this option chain. Now, you have the right to buy at 112 versus the present market at 114. Which would you rather do? Obviously, you'd rather do 112. So you can see that you're getting what we call deeper in the money. The lower the strike price, the more the intrinsic value. The opposite is true with puts. Would you rather sell at 112 or at 114? You'd rather sell at 114. So now the question, would you rather sell at 114 or would you rather sell at 116? And of course, the answer is 116. The deeper or the higher the strike price, the deeper in the money you are. Now, the opposite is true for calls and puts for out of the money. Out of the money means that there is no intrinsic value. No intrinsic value. And then the option strike price right in the middle, this is what we refer to as at the money. And at the money is simply the strike price that's closest to the current stock price. That's at the money. It's at the money right now. It's right where we are trading. So in the money means we have intrinsic value. Out of the money means we have no intrinsic value. At the money means we are at the current price of the stock. Okay? Now, notice that these strike prices that are out of the money have no intrinsic value, but they still have value. There's no intrinsic value, but there is still value. What is the remaining value? We call that premium or time. Time value. Okay? And this is the thing that confuses a lot of people. Premium value represents the premium price for your time. The time to expiration. It is your right to buy. It is literally the cost of the option. The intrinsic value is not a cost of an option. The intrinsic value, you're buying equity. You're literally loading up on equity. Okay? But when you buy premium value or you pay the premium value, you're paying for the likelihood that this option will end up in the money. So you're paying for the right to buy or sell. Premium value declines over time. It runs out. And at expiration, premium value will always be zero. It's always working against you. Okay, so here's the formula for figuring out premium value. Remember that the intrinsic plus premium equals the option price. Well, if you don't know the premium, you flip the numbers around and you go option price minus intrinsic value equals premium. You can always know the option price from the quote. Okay, you can get this from your quote. You can get intrinsic value by doing the formula we just did before, which was your stock price minus your strike price, gives you your intrinsic value, how much in the money you are. Okay, so you can always figure out your intrinsic value based on your strike price and the real price of the stock. So you take your option price minus your intrinsic value, that gives you your premium value. Now, the reality is you're not going to be doing these formulas for every trade. In fact, you probably never do them, hardly, but you need to understand how it works. All right, so that's your premium value. Let's do one here. Your stock is trading at $47.25. You buy a call option with the right to buy at $45. That option costs you $6 per share. How much premium do you have? Okay, well, to first figure this out, we have the option price, which is $6 minus intrinsic value. Well, what's the intrinsic value? Well, it's going to be stock minus strike. So we got $47.25 minus the $45. Okay, so we have the stock is trading at $47.25. We have the right to buy at $45. Okay, that leaves us with $2.25. What does that leave us with? $3.75. So of this $6, the option is $6 a share. Of the $6 a share, $2.25 of it is your intrinsic. $3.75 of it is your premium, giving you a total of the option price of $6 a share. Over time, the $3.75 will erode. It will disappear because at expiration, if the stock never changes price, at expiration, there will be zero premium data. Or, sorry, not data, but premium value. Make sense? Okay, let's do one for a put. Stock is trading at $47.25. You have the right to sell it at $45. Do you want to sell it at $45? Yes or no? No, we've already talked about this. Would you rather sell at $45 or at $47.25? You'd much rather sell at $47.25. So how much intrinsic value do we have? We have zero intrinsic value. Now, the interesting thing is the option cost us $7.25. $7.25, that's your option price, minus zero intrinsic value means 100% of this option is premium. $7.25 is your premium. In other words, it's 100%. If the stock never changes price between now and expiration, the option will eventually become worth nothing because time is working against you. Let's take a look at a couple of different situations here. We're going to do several. Hopefully you can pull this all together, okay? So let's start with the premise that FAS is trading at $114 a share. Is it already 8:30? My goodness, I'm running out of time. FAS is trading at $114 a share. We're going to go long, guys. I'm sorry. We're going to go way long. So FAS is trading $114 a share. You have the right to buy it at $112. You have purchased a $112 call option. That option costs you $3.55. What's the option price? $3.55 is the option price. How much of this option price is intrinsic value versus premium? Well, 114 minus 112 is what? That's $2. Okay, so of the option price, $2 of it is intrinsic value. The remainder is $1.55. That is your premium. Does that make sense? Okay. Let's do another one. You have the right to sell FAS at $115.50. We went with one of those 50-cent strikes. $115.50. Current stock price is $114. What is your intrinsic value? $115.50 minus $114 equals $1.50. That is your intrinsic value. What is the premium? Well, the option price is $2.96 minus $1.50. What does that leave us with? It leaves us with $1.41 premium. Over time, $1.41 will evaporate and it will go bye-bye. At expiration, if the stock does not change price by expiration, this $115.50 option will only be worth $1.50 because that's all the intrinsic value it has. Now, if the stock goes down, the intrinsic value will go up for the put. All right, if it goes up, the intrinsic value will go down. But as long as it stays the same price, that intrinsic value will not change. Now, let's do another one. You have the right to sell at $112. The current price is $114. You have zero intrinsic value. How do I know you have zero intrinsic value? You have zero intrinsic value because you are not in the money. Nobody wants to sell at $112 when you could sell at $114. There's no intrinsic value. Now, interestingly enough, this option costs $1.32. So you have $1.32 premium minus your zero intrinsic value gives you $1.32. $1.32 is your premium. The entire percentage of this trade. In other words, out of this option, 100% could disappear. And it could be worth zero at expiration. If the stock does nothing, it will be worth nothing. That's all or nothing. That's putting it all on the line. If you go in the money, back to our $2.96 example, you had $1.46 of this, so about 50% of it, a little less than that. What was it there? $1.46 divided by $1.46 divided by 296. 49% of this is premium, which means 51% of it will not, it's solid. %49% can disappear by expiration versus 100%. Do you see the difference? So here is the net effect. The net effect of having intrinsic value means the more intrinsic value you have, the more stable the option is. That's what it means. The more intrinsic value you have, the more stable the option is. Now, I see several of you saying, well, how do you lose intrinsic value? Well, what is the intrinsic value built on? You guys can deduce this. The formula for intrinsic value is the difference in the strike price and the stock price. Right? So it's the stock price minus the strike price. So if the stock price changes, your intrinsic value changes. If the stock price changes, your intrinsic value changes. That's assuming that you're in the money. If you're not in the money, then you still have zero intrinsic value. So let's kind of break down how premium changes, because there's a lot of factors that go into premium. Premium value changes often. We use the Greeks to determine this premium change. And then there's another factor that we call implied volatility. Implied volatility is it's a deduction from the stock's volatility, and it's factored in. It's not one of the Greeks. It's just a factor of option pricing. So let's break these down. Implied volatility is an estimate in the volatility based on the underlying stock. Unfortunately, implied volatility is really hard to figure out, and there's really not a known formula for us. It's one of the hardest things to figure out in option pricing is implied volatility. You just kind of look at it, and whatever the option chain says the implied volatility is, that's what it is. You can't really mess with it. All right, so an estimate in the volatility based on the underlying stock. It increases in bearish markets, and it decreases in bullish markets. This is an important factor about volatility. Implied volatility increases in bearish markets and decreases in bullish markets. Market makers also increase implied volatility when they believe that a stock could make a sudden move. For example, earnings. Anytime there is unknown factors, implied volatility gets fluffed up. In other words, they put more money in the premium because they don't know what's going to happen. It's the way they cover their butt to make sure they don't lose money on this deal. Okay? What that means for you is potentially a huge impact on price. Implied volatility can have a huge impact on price. If you have an option that has a high implied volatility, for example, about 20, 25 can start to get into some higher numbers for implied volatility, this can become a major factor in determining the price. If you have a very low implied volatility, it's not factored in too much. Okay, but very high volatility, usually when you pay a very expensive premium for an option, you have very high volatility in that option, okay? So let's go a little bit further. You'll see more about volatility as we get into this a little bit further here, okay? Let's talk about delta. Delta is the most important Greek. Again, the Greeks are the numbers that affect, or the way we measure the pricing of the option. What the delta does is it tells us the relationship of the option price. It's the move of the option price. It's the relative of the option price move to a 1-point move in the stock. Okay? I probably didn't define that too well, but you get the idea. It's the relationship of the move in the option price relative to a 1-point move in the stock. Look at my graph here, and we can figure out if there's a better way to define it. The delta, let's say your delta is 45. If the stock price moves up or down $1, then the option price will increase or decrease 45 cents. The delta tells you what the relative move is. So if the stock moves, if you have a delta of 75 and the stock moves up or down $1, the option will move up or down 75 cents. The option premium does not increase or decrease dollar for dollar with the stock. It's going to increase or decrease based on delta. So then let's assume you have a delta of 98. If you have a delta of 98, a $1 move in the stock will result in a 98-cent increase or decrease in the option premium. Okay, so let's come over here. Let's do some math. This is the most important Greek that I want you to understand. Let's say we've got a call option here at 35, and the stock is trading at 45, and it increases to 45. Oh my goodness, I can't believe I left that error in there. I even saw the error and forgot to go back and change it. The stock is trading at 40 when you purchase it. Please forgive me. Stock is trading at 40 when you purchase it. You buy a call option, that is the right to buy, with a $35 strike price. Okay, so you have the right to buy at 35. The stock is currently trading at 40. The option costs you $7.05. The delta is 71. Now, over the next couple of weeks, the stock increases to $45 a share, as you see on my beautiful graph. How much should your option be worth? Well, understand again that the delta tells you how much your option will increase relative to the stock. So let's say that our stock was 40 and we've gone to 45 because that's what my criteria was. So we went from 45 to 40. That is a $5 increase in the stock. Everybody got that? Everybody sees how I got $5. The stock went from 40 to 45. That's the stock price. Now we're dealing with the option. Okay, so the option cost $7.05, but the stock has gone up $5. How much did the option go up? Well, we're going to simply take $5, multiply it by 71 cents. Why? Because that's your delta. Your delta is 71 cents. So 71 times 5 is $3.55. Your option will have increased $3.55, giving you a total of $10.60. Does this make sense? Great question. Peggy says, not Peggy, sorry. Elias says, does delta measure premium or intrinsic? Delta measures both. John, I just answered your question too. John said, doesn't this forget to add premium? No. How much premium? You guys realize that the premium was already factored in. It was already factored into my price here. Let me do the math. Let me show you again if I can get my slideshow to work. All right. So remember, John, John's the one who asked about premium. John, we purchased when the stock was at 40. That was my error right there. We purchased the $35 call. Stock is at 40. We have the right to buy at 35. We have how much intrinsic value, John? $5 intrinsic value. Now, the option cost us $7.05, John. So if the option costs $7.05 and we have $5 intrinsic value, we have $2.05 premium value. Make sense? The total option price is $7.05. As the stock increases from 40 to 45, the total option will increase that $5 increase times the 71 delta, which leaves us with, was it $3.55? Getting us up to $10.60. Makes sense? So it's on the total number. That's why I say you don't really have to sit around and figure your intrinsic and premium value all the time. What matters is that delta, because the delta tells you how fast the option will increase relative to the stock move. Now, here's the interesting thing. If you had a $3.55 profit, because that was your increase, $3.55, okay, and your option was $7.05 when you purchased it, what is your ROI? Anybody? 50.3%. Now, what if you did the same thing with the stock? You had a $40 to $45 increase. You had a $5 increase on a $40 investment. That was only a 12.5% ROI. The same move on the option, even though you didn't make as many dollars, you made $5 on the stock, you only made $3.55 on the option. But because of the amount of capital you had to put in there, you had a 50% ROI. Does this make sense? Now I'm going to show you something really, really cool. What if I could tell you how fast you would lose your premium? I can. And here it is. It's called theta. Theta refers to the time decay of the premium. It tells you how much premium will decay every day leading up to the expiration, assuming the stock stays the same price. Now, stocks are going to change price, so again, it becomes very subjective because it's always changing, but it does give us a measurement. It gives us something to work with, okay? So assuming that the stock stays the same price, theta tells us how fast we will lose our premium. And interestingly enough, theta increases over time as we get closer and closer to expiration. So let's do an example. If theta is 25 cents every day that the option or that the stock trades, if it doesn't change price, the option will lose 25 cents of premium. It'll just disappear. That is time decaying against you. Because remember, I told you at expiration, it's worth nothing. Okay, so let's imagine on this graph that the orange line represents time decay. This is the premium value, the time value. Okay, let's say, here's my hypothetical up here. The option price is $1.20 with 4 weeks to go to expiration. If the theta is 2 cents, okay, after day one, we'll say the stock price stayed the same price. Okay, so how much do we lose? We lose 2 cents a day. So on day 2 out of this week, okay, day 1, we had $1.20. Day 2, it was $1.18. Day 3, it's $1.16. Day 4, it's $1.14. You guys get the idea. So if the stock price never changes, the time value is still eroding away on you, no matter what. It's always eroding away. Now, here's the crazy thing. As you look at this graph, if you kept going 2 cents a day, you wouldn't be at 0 when you get to expiration. So look what happens. Time value increases, and the theta will start to decay faster and faster as you get closer to expiration. So over here, it might be 2 cents. By the time we get to week 2, it might be 10 cents. And then by the time we get to week 1, it might be 20 cents, and you're losing 20 cents a day. Make sense? All right. That was an aha for some of you. Let's go into Vega. Vega refers to the increase or the decrease in the premium based on a 1-point move in implied volatility. Increase or decrease in the premium based on a 1-point move in implied volatility. I told you implied volatility, we don't really have a way to measure that. All we know is what they tell us. So if they tell us that implied volatility is 21 and our Vega is 11, let's say that the implied volatility goes down. If implied volatility goes down to 20, our option premium will immediately lose 11 cents. Stock doesn't have to change. It doesn't matter. The premium portion of the option will immediately lose 11 cents. Why? Because your implied volatility went down, so it wasn't as risky, so Vega went down. Now, if it goes the other direction, let's say it goes back up, not just to 21, but it goes back up to 22. Well, if the Vega's 11, well, now we actually just made 22 cents. We're back up to 129 now. We actually are better than we started, and the stock didn't even have to change price. Volatility simply increased. All because of the implied volatility changing. See, implied volatility can have a major effect, interestingly enough. It really can have a major effect. All right. Of course, unfortunately, we can't really manage implied volatility that much. The way that you use this, as far as the volatility is concerned, and again, if you follow my rules, I'm going to give you here in just a minute, you won't be hurt too much with all these extraneous premium values, but I'm still teaching it to you because you always ask questions and you're always trying to figure it out, so I'm just teaching it to you. All right, but the implied volatility, let's say you have a high volatility, like say 49. Let's say your implied volatility is 49 going into earnings. And then coming out of earnings, that volatility is cut down to 25. This is very typical. You get into a stock like Apple, actually Apple's worse than this, but you get into a kind of volatile stock, and going into earnings, it'll have a really, really high implied volatility in your option, like 49, or in case of Apple, I've seen it up in the 70s and 80s and 90s. Okay, so you have very high implied volatility. Then earnings come out, everybody knows what's going to happen. Implied volatility is reduced because of Vega. The price of your option just disappeared on you. So if you're long options going into volatility or going into earnings and they suck out the volatility, you just lost a bunch of premium even if the stock didn't change value. Crazy. Now, the opposite can happen too. You can do the opposite. You could buy an option going into earnings, maybe 3 or 4 weeks before earnings when volatility is low, and as earnings is coming, they're raising volatility up. At earnings, it's 49%. You sell it before earnings, and you made money on the volatility swing. This is really getting into advanced strategies, but since a lot of you are actually asking questions similar to this, I'm just answering them. Make sense? All right, let's talk about gamma. Gamma is the rate of increase or decrease in the delta based on a 1-point increase or decrease in the underlying stock. A lot of you don't realize this, but you're going to learn it right now. Your delta changes. Your delta changes all the time, and it changes based on the underlying stock. And the way we measure the delta change is the gamma. Okay? As an option gets deeper in the money, your delta increases. As the option is further out of the money, your delta decreases. So let's say that your gamma is 14.8. Every point of increase or decrease in the stock will result in a 14.8 increase or decrease in the delta. Take a look. The gamma is 14.8. Your delta is 0.56. Stock is at 114. Stock goes up to 115. Your gamma tells you how fast your delta is increasing. So from 114 to 115, your delta just went up, and now you're making 70 cents on the dollar move instead of 56 cents. Now, if it goes down, let's say your stock goes down to 113, well, your gamma tells you that your delta is going to drop by 14.8, but this time it's going to go by 2, so you're down to 41.2 on your delta. Your delta goes up and down based on the price of the stock. More in the money, higher delta. Lower or less in the money, more out of the money, lower delta. All right. Now let's talk about rho. Rho is the rate of increase or decrease in an option premium relative to the risk-free interest rate. Yes, interest rates can have an effect on options. However, here's the reality. On short-term options, they have hardly any effect, like pretty much no effect. They really only affect long-term options, your LEAPS options. The interest rates can actually affect those prices. However, with current interest rates being so low and the Federal Reserve pretty much guaranteeing that they're not going to change them for a long, long time. I think it said 2015, right? So they're not going to change interest rates for a couple years here. Interest rates are where they currently are. They're pretty much a non-factor. If you had really, really high interest rates and they changed, then it would affect the pricing a little bit of your option. It would not really hurt your short-term option. It just really, over time you see it. You don't see it within a 2 or 3 week window. You only see it over a several months window. Okay, but rho is the factor that allows you to reference that. All right, now let's take a look over here, and I know we're running out of time, and I got to wrap this up, but I'm going to give you everything, and maybe we'll find a way to shorten it next time I teach it. I really had no idea tonight was going to be so long. I thought I could blow through this and it'd be interesting. All right. Are you guys interested in this, or are your brains hurting a little bit? I have no idea. I'm still going to keep going, but Kathleen says she's interested. Okay, let's do some examples. Let's take this Q's series right here. And I've put everything on the screen here. Okay, so you got your strike prices, you got all your Greeks, you got your bid and your ask. And let's just come straight through here and look at some various things as we look at these options. First of all, notice I've got September and October. So I've got the weekly and I've got the front month option on here. Okay, number one thing to look at, we're going to go with at the monies. We'll look at 70 strike price because that's the at the money for the October, okay? 70 strike price is 50 cents for September, and it's $1.21 for October. What's the difference? The only difference is it can't be intrinsic value, can it? Well, let's do the math real fast. What's the strike, the current stock price? The stock price is about $70.50, and we're going to call it $70.50, okay? So the stock price is $70.50, and the strike price is $70. That's the stock price is $70.50. The strike is $70. What's our intrinsic value? It's 50 cents intrinsic value. Okay, now we know. If you look at the one that's about to expire in a couple of days here, how much is your premium? It's 50 cents. That's 100% intrinsic value. Wow, that's incredible. Pretty much 100% of that. I mean, in actuality, when I took this screenshot, I think the Q's had a real stock price of about $7 or $70.30 or something like that, but it's pretty close. It's in there. Okay, so you get the idea. 50 cents is essentially 100% intrinsic value. Now, if you come down here to this one, how much intrinsic value do we have here? We have 50 cents intrinsic value, but your premium's $1.21. 121 minus 50 cents leaves us with $1. Uh-oh. My math skills are going to come out. Everybody's going to see that I can't really do math without a calculator. And this is supposed to be an easy one. 71. Just want to make sure I got it right. All right, $1.71. That's not right. It's 71 cents. Forgive me. See, I told you I can't do math. 71 cents is premium value. All because of 4 weeks. An extra 4 weeks. Wow. Now, does this make sense to you guys? Why you would have more premium value going into October than September? Because this option, the $70 that's going to expire on Friday, is going to be worth nothing except for intrinsic value on Friday. So whatever intrinsic value is on Friday, that's what that option will be worth. Make sense? Now let's just come through here and let's take a look at some stuff. What's your delta, relatively speaking? Well, we've got more intrinsic value. We have a 77 delta for the $70 September. We've only got a 55 delta for the October $70 option. Why? The difference? That's just the way it's rolling right now because of intrinsic value. We've got more intrinsic value. The more intrinsic value you have, the higher your delta. The less intrinsic value you have, the lower your delta. Now, if you go in the money, watch what happens. In the money, more intrinsic value, higher deltas. More intrinsic value, higher deltas. Out of the money. Let's go out of the money a bit. Out of the money, no intrinsic value. This is all premium. Look at your deltas. The further out of the money you go, the lower your delta. The further in the money you go, the higher your delta. Ladies and gentlemen, can you tell me why would a $71 call option that expires in 2 days only be worth 5 cents? Because 5 cents is the premium, and you're 2 days from expiration, the odds of that option making you a profit is very, very low. It's got a delta of 15. This stock literally has to go up $1. just to make 15 cents on that delta, or on that option. Probability. You go further out of the money, 71.50, delta of 3. You go further out of the money, 72, delta 0. It's got 0 probability of getting there. Okay, now let's come further over here. Theta. This is time decay. Take a look at this. This is a half a penny. 0.05. This option cannot lose any more money. It's already a penny. So it's going to lose 0.05 tomorrow. This option, the 71, will lose 2.5 cents between now and tomorrow of its 5 cents. It's going to lose half of its value just in time decay overnight because we're about to expire. Let's go to the $71 call option for October. Look at the difference. The delta is 38. The theta is only 21 instead of 25, and the premium is 70. Overnight, we're not going to lose 50% of the value because we've got more time. Does this make sense? Now let's look at the Vega. The Vega tells us how much the implied volatility is going to affect us. So we've got a 1 penny, 1.7 pennies. It's 0.017 is 1.7 cents. Is going to increase or decrease in our option premium if our implied volatility goes 1 point higher. Notice the volatility over here. We're about to expire. Low volatility. You come out a month, we have higher volatility. And it's affecting the premium more. Because we have a higher volatility, we have an 8-cent impact on your option premium. Now look at your gamma. Your gamma tells you that if, look at this, 68 gamma. That's a very high gamma. So